In addition to writing methods that receive arrays, we can also write methods that return arrays. Okay? So in this example, we're going to write a method that we're going to call it createInterval, and it will create what I'm going to call an interval array, which is just an array from the integers m to n exclusive. Okay? So what does that mean? Well, so if we call create interval, yes, okay, yeah. So if we call create interval with, let's say, 5 to 10, this is going to create an integer array with the values 5, 6, 7, 8, 9. So notice that we're making the lower bound inclusive and the upper bound exclusive. Okay, so that's just how we're designing the method. You could very easily change this to make it inclusive on the upper bound as well, and if you want to do that, you could certainly do that. Okay, so fortunately, this method is not very hard to design. But one thing that we do need to take into consideration is what happens when m is greater than or equal to n. Well, what can we do? Well, there's two solutions to this. One is we could return null by default. Remember that null means that there is no array. Okay? The second thing we could do is just return an empty array, and that's what we're going to do for the purposes of this example. We're just going to return an empty array if m exceeds or is equal to n. Okay? So let's handle those two cases separately. So we could combine them into one, but I think it's easier to think about this in terms of two cases, where the first case is the simple case, where m is greater than or equal to n, and the other case where that's not the case, so m is less than n. Okay? So we'll do that. Let's say if m is greater than or equal to n, then just return a new int array that is empty. Okay? So we could do int of 0 here, that would be fine, but I just prefer doing it this way. It doesn't matter, it's the same thing. Okay? Now, for the time being, let's do return null, and let's test this method out. So let's test this file. So this is going to run, so this is actually after I've written the test max, or the max methods. So yeah, that's why those are still there. But let's take a look at what we get here. So let's see, let me just go back up here. Yeah, so these two tests, of course, pass. Okay, so, and we know they pass because we got down to this one, and this one is the first one that failed. So this one passed, and those test the cases where it's equal to and when it's greater than n. Okay, so again, if you were writing this type of method, these are the test cases that I would expect you to include. Okay, now we'll do the slightly harder case, which is when m is less than n. This is when we actually have to do something, right? Okay, so first we need to know how many elements are going to be in this array. And this is actually very simple to compute. It's just going to be the difference between n and m, right? So for example, if n is 4 and m is 3, then 4 minus 3 is going to be 1. So the resulting array has one element. If we have 10 and 3, the resulting element, or the resulting array is of length 7. And you may wonder, well, what happens if one of the bounds is negative? And actually, we need a case for when both bounds are negative. So I'll write that. So in this case here, we're just going to do, again, the same thing, just max minus min. Because if the lower bound is negative, but the upper bound is positive, then 3 minus negative 3 is 6. Okay, so we get 3 minus negative 3, which is 6, and there are 6 elements in this array. And then if we do this, we're going to get negative 1 minus negative 3, which is like saying plus 3, which is 2. And because n is always greater than m, this sum will always be positive. Okay, and I'll leave it to you to figure out, like, or to, I guess, reason through why that's the case. I think it's obvious, and I think that most people will be able to see that, but if you need help convincing yourself of it, just think about the properties of addition and subtraction over negative numbers. Okay? So we'll say that we're going to create a new array. So we'll just call it new r is equal to new int, and then we're going to do n minus m. Okay. So think about what would happen if we did m minus n. That would mean that we're going to get a result that is always negative, because if m is strictly less than n, then this result will be, like if we did this, for example, then this result would always be negative, and you can't have an array of a negative size. That just doesn't make sense. Okay, so let's fix that. And now, we're going to do something very simple. We're just going to loop from int I equals m, and then I is less than n, and I plus plus. Okay? Now, you may be wondering, well, okay, so then we can just do new r at I is equal to I, right? Well, no, we can't just do that, because what will happen is, what happens if we do that with this array? So the first value of I is 3, so we'd start off by skipping over indices 0, 1, and 2, and we start at 3, and we can't do that. So the simplest way to get around that is just to also subtract the lower bound from this index. Okay? So we start our counter off at m, and we loop until it's less than n. Okay? So that would get us from 3, like in this example, it would go from 3 to 4 to 5, 6, 7, 8, 9. But when we're indexing into the array, we actually want it to go from 0, 1, 2, 3, 4, 5, 6. Okay? And if you need convincing of that, then I encourage you to run the debugger and to see the possible values of I, and also the values of I minus m. Okay? And we'll just return new array. And let's run this test, and all tests should pass, and indeed they do.